Hello students, let's continue with polynomials, solving certain examples on algebraic identities. So let's take a look at example 17. It is asking us to evaluate 105 into 107, however, without multiplying directly. So how are we going to do this? Obviously, we are going to take a look at algebraic identities and do it, right? So let's see, 105 can be written as 100 plus 5, right? And 107 can be written as 100 plus 7, right? So I'm going to use this to solve our example. Therefore, 105 into 107 is nothing but 100 plus 5 into 100 plus 7. Does this resemble any identity? Take a look. Yes, it does resemble the fourth identity, x plus a into x plus b. X is same here, a and b are different, right? So let's write the formula first. We know that x plus a into x plus b is equal to x square plus a plus b into x plus a into b, right? This is using identity 4, right? Identity 4. I'm just writing I4 instead of identity 4. Therefore, 105 into 107 is equal to x square. So 100 square plus a plus b, which is 5 plus 7, plus a into b, which is 5 into 7, and x here. Correct? So x square plus a plus b into x plus a into b, right? This is equal to, now 100 square would be 100 into another 100, right? So 4 zeros. Why? Because you're squaring it up. This is not an emoticon, this is a 0. 7 plus 5 is 12. So 12x plus 35. I'm sorry, this was not x, your x was 100. Let me just redo it quickly. 100 square plus 5 plus 7 into 100. My bad. Why? Because a plus b, 5 plus 7 into x, but we have x as 100 here, that's why. Plus 5 into 7. Right? So this is 100 square, 1 0 0 0, 4 zeros because we are squaring 100, plus 5 plus 7 is 12, so 12 into 100 plus 35, right? So this is equal to 1 2 3 4 plus 1200 plus 35. So let's calculate this. 100, 100, another. So it is 10,000 plus 1200 plus 35. You add these, you get 5, 3, 2, 1, 1. So your answer is 1, 1, 2, 3, 5. 105. 107. So do you notice that algebraic identities is making our work so simple? Imagine calculating 105 plus into 107, it would take hell lot of time, but using algebraic identities our work looks neat, plus we are able to solve this in very less time, thereby reducing our efforts and not getting really irritated, right? So now let's go ahead and solve example 18. We have two subsections to example 18. So now we need to factorize. That means we have to write this in the you have to split this into its factors, product of its factors. Here they've already given us the factors and we had to expand it. So factorizing is the opposite of expansion. You have to write the factors over here, product of factors. Now again this we are going to solve using algebraic identities, correct? So let's say 49a square can be written as 7 square into a square, right? Seven tens are 70, so 7 can be written as 7 into 10 ab, correct? And 25b square can be written as 5 square b square. So you notice that you have the first term here 7 and 5 square, correct? But we have 10 over here. So how about splitting 10 further into 5 into 2? Correct? Now this can be written as 7a the whole square, right, plus 2 into 5 into 7 into 5 into ab plus 5b the whole square. Since it was 7 square and a square, I just took them both in bracket and squared it up. Similarly for 5 and b, it was 5 square b square, so I put them together in a bracket. So when you open the bracket, it would be 7 square a square and 5 square b square. Clear? So does this resemble any of the formulas here? Take a look. Yes, it does. This is identity 1, right? See, you have a square, so a square plus 2ab plus b square. Therefore, using identity 1, I am just writing identity I1 instead of identity 1, okay? Using identity 1, I get this is equal to 7a, or rather I will just write identity 1 so that you do not forget it. The more we write it, the more we practice and the more it gets engraved in our minds, right? So you get a plus b the whole square is equal to a square plus 2ab plus b square, right? This is identity 1, correct? Therefore, this equation is equal to 7a plus 5b the whole square, right? So you can just write it as 7a plus b into 7a plus b, 5b, right? But this is the actual way of writing. Why? Because we have identities given in this format. So do not split it preferably. Plus you're just increasing your number of steps. So just stay over here, okay? So I'm erasing this. Therefore, this is your answer, right? Let's proceed to the other example of the same question, that is example 18. Now we have 25x square minus y square upon 9. Now something strikes when you look at these identities. You have anything like, you know, a square, x square minus y square. Take a look. Yes, we have the third one, right? A square minus b square. And then the expansion, right? So now let's see whether we can, you know, turn twist this to get an expression similar to this, right? See. This can be written as 25 is the square of 5, 4 is the square of 2 and 9 is the square of 3. So we can easily square these up, right? So this can be written as 5 square x square upon 2 square, correct? Then y square upon 3 square, okay? So this can be written as 5x upon 2 the whole square, right, minus y upon 3 the whole square. See, now we have a square minus b square, okay? So now, what does our identity 3 say? We know that a square minus b square is equal to a plus b into a minus b. So in your exams, wherever you are splitting terms, whenever you are making changes or referring to the identity, you can write it over here in brackets, or you can write it as a sentence over here. Just give reference that what are you referring to in order to prove what you are doing, right? So your examiner will understand better that you know what you are doing and not copying from someone else. So this will therefore be equal to 5x upon 2 plus y upon 3, right, into 5x upon 2 minus y upon 3. This is your answer. So therefore we have factorized these two terms, that is, we have written them into the product of their factors. Okay, so we have completed 2 solved examples. We will continue later in the forthcoming lectures. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.